think last class I mentioned that the mucus tends to be thick and acidic, which is harmful to spermatozoa, and that mucus blocks the endocervical canal. So it makes it more difficult for spermatozoa during most of the menstrual cycle to make their way up into the uterine cavity. But around the time of ovulation, that cervical mucus begins to change. It becomes more elastic. If you look at it under the microscope, you see what a process called ferning, where little channels, openings, pathways develop within the mucus, so that now spermatozoa can cross it more easily. In fact, they're guided by the ferning. And then the mucus becomes more alkaline. So it's like right around the time of ovulation, the door is open. It's like the uterus is saying, come on in, boys. When I was in medical school, we did reproduction with endocrine, and what happened is all the male students had to submit a semen specimen, and all the female students had to submit a specimen of cervical mucus. And so we would look at that, and that was the specimens we looked at in physiology class under the microscope. But it was interesting that with regard to the mucus, you could see the ferning and the changes that occurred, because when they submitted the mucus, and they had to submit it different times during the month. And so you could see as ovulation approached, the cervical mucus changed. That was the whole point. Now, one thing you'll notice from a growth standpoint is that if you collect some mucus, and you always want to use gloves, you can take it, you can collect it on the tips of your gloves, and you can separate it. They can kind of be stretched out between your two fingers. As you near ovulation, the mucus becomes progressively more elastic. So you can stretch it out to about 10 centimeters or more around the time of ovulation before it breaks. And that's a sign of increasing estrogen levels. That's a sign that you're right around ovulation. Whereas if it breaks early on, you're nowhere near. So one of the things we had to do was take some of that mucus, put on some gloves, and stretch it out. And we're really performing a spin archive test. Another way to time ovulation is to do a basal body temperature. It means that every morning, before you get out of bed at the same time, check your body temperature. You can use special thermometers that have more gradations, more marks, so that you can see a drop in temperature right before ovulation, followed by a spike. Okay, and you every day you mark on a little calendar, and you'll see a little drop and then a little spike right around the time of ovulation. So that's another way of timing ovulation. The third way is to pee on a stick. Not just any stick. It's a urine dipstick that assesses for the presence of luteinizing hormone. Like you just can't go outside. So this has a little colorimetric method that detects the increase in luteinizing hormone that occurs around the time of the cycle. So for instance, here's the spin archive test. You know, early on this thing may snap at about 2 or 3 centimeters. But as you near ovulation, 10 centimeters is kind of a magic mark. You get to, if you do OBGYN, you get to learn what about 10 centimeters is. Why is that an important number?
Because that's how much you dilate.
Yeah, that's how much you dilate right before delivery, up to 10 centimeters. You know, once you reach 10 centimeters, things are about to go forward. Here's a basal body temperature chart where you can see, okay, these are the morning temperatures. They're fluctuating a little bit. And then right before ovulation, you have a dip. And then right after ovulation, spike. That's another way to do it. Okay. If we were to look at the uterine wall under a microscope, you'd see smooth muscle making up the myometrium, and then superficial to that, heading toward the lumen of the uterine cavity, you're going to see an endometrium. And there are 2 major layers to the endometrium. The deepest layer is called the stratum basalis. This is the layer that's not lost. This is the layer of the endometrium that remains behind even with menstruation. Whereas the more superficial layer here is called the stratum functionalis. This is the layer that's lost during the menstrual phase. So down here, this would be the myometrium. This deeper layer right here, stratum bassalis. Up here where you have looser connective tissue, that's the stratum functionalis. Now, the uterine wall is fed by a uterine artery, which gives rise to arcuate arteries. Their branches supply the uterine wall. Okay. So here we see radial arteries, which are simply branches of these arcuate arteries that come up and serve the endometrium. These straight arteries are providing blood flow to the stratum bassalis, whereas these longer, more coiled arteries, they're called spiral arteries, are serving the stratum functionalis. So as we regenerate a new stratum functionalis with each new menstrual cycle, these new blood vessels grow, and as they mature, they become more spiral or coiled, okay, traveling all the way up to the surface. This surface epithelium is a simple columnar epithelium that invaginates and forms endometrial or uterine glands. These glands produce glycogen that are going to be that's going to be the source of nutrients for that initial placenta, that initial implanting embryo. So again, these are just some charts here of hormone levels. This one shows gonadotropins, LH and FSH during the menstrual cycle. Here we see what's being released from the ovary. You know, during the first half, it's mostly about estrogen, whereas during the second half of the cycle, as a result of production of corpus luteum, the major hormone is progesterone. Okay, so it's the developing follicle that produces the estrogens, where it's the corpus luteum that's responsible for progesterone. Under the influence of estrogen, rising levels of estrogen, look what happens following the menstrual phase. We regenerate a new endometrium. And you can see the glands beginning to form. Initially, they're very straight. And when we look under the microscope and we see very straight glands like these, we know that we're in the early phase, the proliferative phase of the uterine cycle. But now, following ovulation, you see the glands are beginning to become more coiled. And at this point, they're beginning to secrete glycogen. So when you see coiled glands under the microscope, you know that, okay, this is the secretory phase. At the same time, during the secretory phase, these vessels are taking on a spiral shape. And they're very, very sensitive to the influence of progesterone. It's under the influence of progesterone that they're coiling and maturing. Now, if progesterone is withdrawn, these spiral arteries undergo vasospasm. And when they undergo vasospasm, then that means that the endometrium, specifically the stratum functionalis, becomes ischemic and begins to break down. Okay, so it's that loss of progesterone support, that withdrawal of progesterone, that brings about vasospasm that results in ischemia to the stratum functionalis, and eventually it's necrosis and sloughing. So then we start all over with the new menstrual phase here. So the cycle repeats. This is the external genitalia. What are the two names we use for the external genitalia? Vulva and pudendum. Okay. This region up here is the mons pubis. it's really a fatty pad and, that sits on top of the pubic symphysis. Pubic bone. That's a little translation. You move posteriorly from the mons pubis, these structures of the labia majora. We said the labia majora are homologous to the scrotum. Okay. The labia majora usually has pigmented skin. It's got sweat glands and spacious glands. And it extends back to the perineum. Now, if you go medial to the labia majora, then you have the labia minora. The labia minora are different. They're hairless. No sebaceous glands, no sweat glands. Anteriorly, they come together to form the hood on the prepuce of the clitoris. So the hood of the clitoris is derived from the labia minora. This space between the two labia minora, sitting in front of the urethral opening and in front of the vaginal opening, this space is called the vestibule. The term vestibule, by the way, it's used a lot, is kind of an entrance. Have you ever gone to church and they've talked about the vestibule of the church? Okay. The vestibule of the church is where people first enter, and this is where they meet, they converse. Okay? But that's not where the ceremonies are occurring. Okay? This is just where we gather. But if you want, the action is on the inside. Okay, so you have to pass through doors from the vestibule into the church, okay, to attend the ceremony. Okay? And it's very analogous to what we have here. This is the vestibule, but reproduction occurs further inside. That's where all the action is. Now, JJ, you were asking about the hymen. The hymen is this tissue here that partially covers the vaginal opening. Okay? So generally, when you're born, you have an intact hymen, but that tissue is torn, okay? And much of it is lost as you mature. If this is the vaginal opening, anterior to it right here is the urethral opening. But notice they both open into the vestibule. And if we move anteriorly, clitoris. The clitoris is homologous to the penis. That the clitoral head has a tremendous number of sensory nerve endings, just like the glans penis. The difference, though, is this. This is the penis in cross section. This is the clitoris. What's missing? Not an opening. A corpus spongiosum. They have a pair of corpora cavernosa, but no corpus spongiosum. So this is these cylinders of tissue. These are erectile chambers. These are chambers that are filled with sinusoids that can be expanded by blood flow. Okay. Now if you look really closely, extending down from the clitoris, this is a clitoral bulb, which is still further more erectile tissue. But then right medial to it, right here, is the greater vestibular gland on each side. Another name for the greater vestibular gland is the Bartlett's gland. it's homologous to the vulvourethral gland. Like the vulvourethral gland, the greater vestibular gland begins to produce secretions during the arousal phase of a sexual encounter. Whereas the male is responsible for developing an erection to facilitate intercourse, the role of the female is to provide lubrication for intercourse. Now, the vulvourethral glands provide a little bit of lubrication, but it's really the vaginal walls that begin to release a lubricating fluid. People say they begin to sweat. But that contributes more than the vulvourethral glands, actually. But again, this occurs during the arousal phase. This region here, between the vagina and the anus, this would be the clinical perineum, perineum. Now, the anatomical perineum is a broader area. The anatomical perineum extends all the way to the pubic symphysis. But from a clinical standpoint, the perineum is considered that tissue from the vagina to the anus.
This is the one with the eye, right?
The eye, yeah. So that one of the concerns during childbirth is that you can create a tear into the perineum that can extend all the way to the rectum. It's called a fourth-degree tear. So in order to prevent that, what an obstetrician will sometimes do is what's called an episiotomy. They'll make a little incision and direct it away from the anus. So that, number one, if it is a large child that's destined to create a tear, now we have a control tear. It's easier to suture up. The edges are smooth, and it's directed away from the anus.
What happens when
Well, then there can be complications. Even if you suture up properly, there can be problems with fecal incontinence. What's that?